Stoichiometry, one-step conversions. This is a one-page double-sided worksheet to help you practice these stoichiometry one-step conversions. I'll refer to this flowchart as we are doing these problems. So let's take a look at our first example. It reads that we have silver and nitric acid. It's reacting to form silver nitrate and water and this thing called nitrogen monoxide. All right, first question. How many moles of silver are needed to react with 40 moles of this nitric acid? Well, let's first start annotating. We're trying to convert to this, how many moles of silver? We are starting with 40 moles of nitric acid. Okay, what we're trying to do in this problem is, notice we're trying to go from moles of one substance to moles of another substance. So on this flowchart, moles of A to moles of B. Notice it passes through this thing called a mole ratio. A mole ratio is a conversion factor that lets you convert from moles of one substance to moles of another substance. And when we have a mole ratio, we get the numbers from, let's see, the balanced chemical equation. All right, so remember that. We are going to require a mole ratio here. Let's start by writing down the first thing, which is usually what we underline. 40 moles of HNO3. You can abbreviate moles with MOL. We are trying to convert, so times and draw a line. Times, draw a line. The unit that goes on the bottom is usually the unit that we started with, which is right here. Moles of HNO3. The unit that goes on the top is what we're trying to convert to. We're trying to convert to moles of another substance, which is moles of Ag, silver. Notice that we have a mole ratio. On the flow chart, when we have a mole ratio, we get the numbers from the balanced chemical equation. Now, the balanced chemical equation is right here. Okay, so how many moles of silver do we have? And how many moles of nitric acid do we have? So according to this, there's 2 moles of silver, there's 4 moles of nitric acid. So we write 2 moles of silver, so that would be on the top. And then there's 4 moles of nitric acid, so that would go on the bottom. The unit that cancels out here is moles of nitric acid and moles of nitric acid. The unit that we're left with is moles of silver, and that's what we want, don't we? So that means we can stop. We'll write an equal sign. Now what we're supposed to do here is take 40, multiply it by 2, and divide it by 4. So in the calculator, that's what I'm going to do. 40 multiplied by 2, divide by 4, and what we should get is, I don't know if you can see this, but I've got 20. So let's see, 20, and the unit that is left is moles of silver, which is what we wanted. 20 moles of silver is needed to react with 40 moles of nitric acid. That should make sense. So that's our first one. That's a mole ratio conversion. The next problem, let's take a look at this. Letter B, same reaction, by the way. If you produce 30 grams of silver nitrate from the reaction, how many moles of silver nitrate is that? Okay, we are trying to figure out how many moles of silver nitrate, okay? And we're starting from 30 grams of silver nitrate. If we have 30 grams of silver nitrate, how many moles is that? Well, let's take a look. So remember that we have 30 grams of silver nitrate. How many moles of silver nitrate is that? According to our flow chart, we're starting with 30 grams of silver nitrate, grams of A. We're converting to moles of silver nitrate, so it's moles of the same substance, moles of A. And what do we need to do this conversion? Well, it passes through this arrow, and this is a molar mass. So to do this conversion, we need a molar mass. That's the conversion factor that we need. And let's see, if we have a molar mass, where do we get the numbers? Oh, the periodic table. We need a periodic table to get the molar mass of a substance. All right, so what do we do from here? Well, we're going to start by writing down what we underlined. So we're going to write 30 grams of silver nitrate. We're going to draw times and a line so we can convert this. The unit that goes on the bottom is the unit that we already wrote down. So grams of silver nitrate goes on the bottom. The unit that we're trying to convert to is the unit that is circled. Let's see, we're trying to convert to moles of silver nitrate. So that goes on top. Okay, and now we have to get the numbers. But notice that this thing is actually a molar mass because it has moles and it has mass. So according to the flowchart, you get the numbers from the periodic table. So we're looking for how many grams there are per mole of silver nitrate. You have to add up the molar mass of silver. There's only one of them. Nitrogen, there's only one of them. And oxygen, but there's three of these. So you have to add them all up. So um, I'll display the elements on a thing and let you try to confirm this. Okay, so again, one silver, one nitrogen, three oxygens. I'm getting 169.88 for the molar mass. So that's how many grams there are. This number is how many grams there are for 1 mole of silver nitrate. So if you think about what that means, where did the number go? 169.88 grams, so that goes on the bottom, for every 1 mole of silver nitrate. So 1 goes on the top. All right, the unit that cancels out here, let's see, grams of silver nitrate and grams of silver nitrate. We are left with moles of silver nitrate, which is what we need. So that means we can go ahead and throw in our equal sign. So in this problem, we're starting with the number 30, and since this number is on the bottom, you would divide by 169.88. So in a calculator, let's see what that gives us. Okay, a long string of numbers, but it's approximately, if we round up, it's approximately 0.18. All right, that's how many moles there are. So that's what I'm going to write. I'm just going to do 2 decimal places and not bother writing all the other numbers. So 0.18. And the unit, again, if you ever forget, it's the unit that we didn't cancel out. We have 0.18 moles of silver nitrate. That is how many moles there are in 30 grams of silver nitrate. All right? So that's our final answer right there. Okay, let's take a look at letter C. For letter C, we have the question, still about the same reaction. How many molecules of H2O are there if 0.28 moles of H2O was produced from the reaction? Okay, so this reaction produces 0.28 moles of water. How many molecules of water is this? All right, so we're going from moles of water. How many molecules of water is this? There should be a lot. Molecules are really tiny things. So let's go to our flow chart. We are given 0.28 moles of water. Let's see, what is that? Moles is this thing, moles of water. And we're converting to molecules of water. A molecule is a really tiny particle. So now, if it's water, we're still talking about the same substance. So that means we're talking about a particle of A still. It's still A. It's the same substance, all right? But we're talking about particles now. So notice that this passes through this one arrow. And it says Avogadro's number here. That's another conversion factor that it relates to. If you look at Avogadro's number right here, it says 1 mole is equal to 6.02 times 10 to the 23 particles. So, well, what this means is 1 mole of anything is that huge number. That's Avogadro's number, all right? So 1 mole of anything is this many things. Okay, let's go back to our problem here. I forgot to underline what we're starting with and circle what we're trying to convert to. So we're starting with 0.28 moles of water. We're trying to convert to molecules of water. Okay, let's start by writing down what we underlined. So that's how we would write it, 0.28 mole H2O. We're trying to do a conversion, so we do a times and a line again. The unit that goes on the bottom is the unit that we started with, moles of H2O. The unit that we're trying to convert to is a unit that we circled, molecules of H2O. All right. Now, what we have here is moles and molecules. So moles and particle. If you have a moles and a particle, according to the flowchart, this relates to the conversion factor involving Avogadro's number. All right, and Avogadro's number is huge. In fact, it's kind of big to write. So what we can do is we can abbreviate it so that we can save some space. 1 mole of anything, like water, 1 mole of water is 6.02 times 10 to the 23 of that thing, water. So instead of writing that huge number, I'm going to write this, which represents Avogadro's number. It represents 6.02 times 10 to the 23, all right? So that we don't make this all messy. Okay, so take a look at the units that cancel out here. What we have is moles of H2O and moles of H2O that cancel out. And let's see, we are left with molecules of H2O, which is perfect. And what we're going to do is we're going to type this in the calculator, 0.28 times Avogadro's number. All right, 0.28 times Avogadro's number. If you forget what Avogadro's number is, for the time being, just take a look at the flow chart. This number is 6.02 times 10 to the 23. And in order to type all of this in the calculator, I'll show you how we would type it in the calculators that we have. So what we would type is 0.28 times 6.02 EXP, there's a button for that, 23, and then you hit the equal sign. All right, that's how you would type it in our calculator that we have in class. I'm going to go ahead and type it in my calculator. Okay, so in my calculator, this is what I'm getting, and I want you to recognize this, please. This is about 1.68, and then do you see the E right there? The E represents times 10 to the, all right, so this is about 1.68 times 10 to the 23. Okay, that's how you would read this. 1.68 times 10 to the 23. So that is our answer. Let's see. Throw an equal sign. 1.68 times 10 to the 23. That's the answer. But we're missing the unit. The unit is molecules of H2O. All right, and it should be that way because 1 molecule of H2O is incredibly tiny. If you have 0.28 moles of it, you should have a lot of molecules, regardless, because molecules and atoms are super tiny. If you ever have a unit that has molecules or atoms, you should have a lot of it. And this makes sense. We have a huge number here. All right. I'm going to go ahead and do the number 1 on the next page, and I want you to try to do this on your own first. And if you are stuck, then fast forward through this video and see if you can follow along, or you can fast forward to just confirm your answer. All right. Okay, in this next problem, number 1, we have a different balanced chemical equation. Okay, so notice that we have N2H4 reacting with N2O4, and it's producing N2 and H2O. All right, now in the first problem, you used 24 grams of N2H4 in the reaction above. How many molecules of N2H4 is that? Let's annotate. We're converting from grams of N2H4 to moles of N2H4. Grams of N2H4 to moles of N2H4. We're converting from 24 grams of N2H4 to moles of the same thing, moles of N2H4. So this requires a molar mass. If you have a molar mass, look at the periodic table to get the numbers. Start by writing what we underlined. Times, draw a line, we're doing a conversion. Unit that goes on the bottom is the unit that we started with. The unit that goes on the top is the unit that we circled. This thing, again, is a molar mass. If you have a molar mass, you look at the periodic table. So we have, by the way, 2 nitrogens, 4 hydrogens. So you have to add those all up. All right, I'll pop up the element card so you can calculate that and confirm. Okay, I'm getting a molar mass of 32.05. That's how many grams there are for 1 mole of N2H4. Again, that's how many grams there are for 1 mole of N2H4. All right, the unit that cancels out here, grams of N2H4, grams of N2H4. The unit that we're left with is moles of N2H4. That's what we want. So I'm going to go ahead and throw in the equal sign. According to this problem, take 24 divided by 32.05. Throw that in the calculator. What do we get? I'm getting something, I'm going to round this. I'm getting about 0.75. That's how many moles there are. 0.75 moles of N2H4. All right. And there we go. So that was a mole to mass conversion, or mass to mole conversion, technically. Okay, next problem. What do we have here? If the reaction produced this many molecules of N2, so that's 7.8 times 10 to the 23, that's a huge number. If the reaction produced that many molecules of N2, what amount of moles of N2 is that? So we produced a huge amount of molecules of N2. How many moles of that molecule is there? So let's annotate first. What moles of N2? We're starting with a huge number of molecules of N2. So 7.8. Let's talk about the flowchart first. So we're talking about molecules. Molecules and atoms are considered particles. They're tiny things. And we're trying to convert to moles. So a particle to a mole conversion. Let's look at our flowchart. According to our flowchart, we're trying to convert from a huge number of molecules of N2. That's this, particles of A. We're trying to convert to moles of the same substance, N2. moles of A. This involves Avogadro's number. If you have Avogadro's number, or the conversion factor, 1 mole of that substance is 6.02 times 10 to the 23 of that thing, okay? So it's a huge number. 1 mole of anything is a huge amount. All right, so let's see, what do we got here? Write down what we underlined. We're trying to convert to moles of the same substance, so times, draw a line, we're doing a conversion. The unit that we write on the bottom is the unit that we started with, molecules of N2. The unit that we're trying to convert to is the unit that we circled, moles of N2. Now, again, according to the flowchart, if you have a particle and a mole conversion factor, that's Avogadro's number, 1 mole of anything is 6.02 times 10 to the 23 of that thing. So, let's see. 1 mole of N2 is 6.02 times 10 to the 23 of N2, molecules of N2. But instead of writing that huge number, I'm going to write this, which represents that huge number, okay? So that, again, it doesn't mess with the format right here. So what do we got? Units. Units that cancel out. Molecules of N2 and molecules of N2. Okay. So now we have moles of N2. Perfect. Throw in our equal sign. And let's type this in our calculator. What do we have? 7.8 times 10 to the 23, and then divided by 6.02 times 10 to the 23. So I'll show you how to type this in your calculator, just in case if you were wondering. This is what I would type in the calculator that we have in our classroom. 7.8 E 23, and then the divide by sign, and then Avogadro's number, 6.02 E 23, and then finally hit the equal sign. So I'm going to go ahead and do this on my calculator. I encourage you to try this to see if you can type it correctly. Okay, so this is what I'm getting. I'm getting about 1.29, but if you round this up, if you wanted to round it up, it would be about 1.30. I'll round it up. So 1.30 moles of N2. 1.30 moles of N2. Okay, now does this really make sense? If you think about it, 1 mole of any substance is 6.02 times 10 to the 23, right? And what we have here is a number that's a little bit bigger than 6.02 times 10 to the 23, 7.8 times 10 to the 23. So it's a little bit bigger than 1, all right? So yeah, it should make sense here. All right, the last one I'm going to cover is number 1, letter C. It's still pertaining to the same reaction. How many moles of N2H4 would be necessary to produce 4 moles of N2? How many moles of N2H4 would be necessary to produce 4 moles of N2? Let's see. Let's do our annotations. We are trying to convert to moles of N2H4. We are starting from 4 moles of N2. These are different substances. These are moles of different substances. So moles of N2 is what we're starting with. Moles of N2H4 is what we're trying to convert to. If you look at our flow chart, let's see, we're starting with moles of N2, just moles of one substance, and we're trying to go to moles of N2H4. That's a different substance. Moles of B, a second substance, all right? So this requires a mole ratio. And for a mole ratio, we get the numbers from looking at the balanced chemical equation. All right, let's do this. Let's start by writing down what we underlined. And we're converting to moles of a different substance, so times, and draw a line. Now, what unit goes on the bottom? It's the unit that we already wrote down, moles of N2. What unit do we convert to? Let's see, it's the one that we circled, moles of N2H4. Hey, this thing is a mole ratio. It's got moles on top, moles on bottom. It's a mole ratio. And according to the flowchart, a mole ratio, you need to look at the balanced chemical equation. Where is that? Right here, right at the beginning. Okay, how many moles of N2H4 are there? How many moles of N2H4 are there? There's 2. And how many moles of N2 are there? How many moles of N2 are there? There's 3. All right, so there is the numbers. We're just going to write it in the appropriate spots. 2 moles of N2H4, 3 moles of N2. Let's look at the units that cancel out now. Moles of N2, moles of N2. The unit that we're left with is moles of N2H4. What we want to type in our calculator is, let's see. In a calculator, we're starting with 4. We're multiplying by 2. We're dividing by 3. 4 times 2 divided by 3 is what we're getting. A lot of 6's again for some reason. 2.66666. Okay, so let's round that. 2.67. 2.67 moles. 2.67 moles, and we're converting to moles of N2H4. So when we're doing this reaction, if you start with, or if you're producing 4 moles of N2, you would need to start with 2.67 moles of N2H4. Yeah, that makes sense. Okay, I really want you to try these on your own, and we'll see if when we check it if you got it right. All right. Okay, and if you don't get it right, you can retry it and resubmit. All right. Have a good day.